In this video, we're going to do another example of finding the surface area of a revolution. So we're going to rotate the curve x equals to e to the 2y on the interval from 0 to 2 for y's. We're going to do this about the x-axis and about the y-axis, and all we're going to do here is set up the integral. We're not going to evaluate anything. So remember, when we go about the x-axis, our surface area formula is 2 pi integral from a to b of y ds. Again, ds is our arc length differential. So in these problems, they're all going to be either 1 plus derivative with respect to x squared or 1 plus derivative with respect to y squared under square root. So the only thing we have to worry about really is what we're plugging in for the other piece of the integrand. So in this case, if we're going about the x-axis, the radius is given to us by y. The function is given to us in terms of y, so I don't need to replace anything for that y. So we get the 2 pi times the integral from 0 to 2 of y times the square root of 1 plus 4e to the 4y. 4e to the 4y is what we get when we square 2e to the 2y. Now, if we're going to do this about the y-axis instead, our radius now becomes x. Notice that our differential for arc length stays exactly the same. That doesn't change. Notice it's the same as it was when we rotated about the x-axis. The only thing that's going to change is what our radius is. Our radius is given to us by the x-coordinate. The x-coordinate is a function of y, so we replace x with e to the 2y. So we get 2 pi integral from 0 to 2 of e to the 2y times the square root of 1 plus 4e to the 4y dy.